Viewers, welcome to the series of videos where we are analyzing outliers. So in this video, we will understand how we will identify whether a given set of data have outliers or not, provided the data is not normally distributed. In my previous videos, I have explained the concepts of z-score method, Grubbs method and Dickson test method, and primarily on all those three cases the data need to be normally distributed. However, in this method, which is called interquartile range IQR, we can identify whether the data contains outlier or not, even if the data is not normally distributed. Let's get into the video. As we saw in the previous methods, where one of the prerequisites for us to apply that method is the data should be normally distributed. For all the three methods, the z-score method, the Grubbs test method, as well as the Dickson test method, in all the cases the prerequisite is the data should be normally distributed. However, in the interquartile range method, it's not necessary that the data need to be normally distributed. Still, we can use this method to identify whether the data contains outlier or not. So what is the logic of a interquartile range? So in our previous video where we have discussed about box plot, we have clearly explained the logic of what is this center 50 data all about. I will even share the link of the video where we have explained about box plot in the description. So if you see this particular data, you have maximum values. So for example, you have maximum values here, you have minimum values here, but what will happen is if you have certain number of data points by using the percentile formula. So we have also explained what is a percentile formula. For those who do not understand what is a percentile formula is converting your rank in a scale of 100. For example, if there are 30 people reporting to a manager, if there are 30 assistant managers reporting to a manager, this 30 people will be considered as a peer population. This 30 people will be considered as a peer population. In this 30, if somebody is, let's say, getting 32.5 lakhs per annum, this is lakhs per annum, right? So 32.5 lakhs per annum as the salary, and let's assume that individual gets the highest salary, and he will be given 30th rank from the top. He will be given 30th rank from the top, right? Okay. And let's say somebody is getting 21.8 lakhs per annum and he is the minimum. He will be given the number one rank in terms of the least. That means he is the person who gets the minimum salary. Now if I want to know the percentile, right? So what I will do, my rank from the top divided by my peer population. So that means I am scoring 100th percentile, right? Okay. Someone else here will be scoring, let's assume 23 lakhs, 23.4 lakhs. Let's assume his rank is in this group of people. Let's assume his rank is, let's say his rank is 19. Then what will happen? His rank will be 19 divided by 30. So his percentile value will be 0.63. So in other words, he is at the 63rd percentile. So this is the logic of percentile, right? Okay. Now coming back, what we will do, if we have a particular sample of data with certain number of data points, your P25, or in other words Q1, will talk about the 25th percentile. Q3 will talk about the 75th percentile, and the distance between your value of Q3 and Q1 is called your interquartile range. The distance between maximum and minimum is generally called as your range. The distance between the value of P75 and P25 will be called interquartile range, IQR. So first what we need to do is we will use the percentile formula. So this is the percentile formula. How the percentile formula works, we have already uploaded a separate video. I'll share the link of that video in the description. You can have a look at it. So if I say percentile, and then if I select all my data points, and then I can put a comma. After comma, I can put any value between 0 to 1. Now I'm going to say 0.25. Why I am entering 0.25? Because I want to know the value of 25th percentile. So the value of data point 25th percentile is 5.32. Now what I do, I take the same formula. Sorry. I take the same formula. Now I have to enter 0.75 because I want to know the value of 75th percentile. Okay. So I have calculated the value of 25th percentile. I have calculated the value of 75th percentile. Now if I find the difference between these two values, I call it interquartile range. IQR is nothing but the difference between the value of P75 and value of P25, and that is called interquartile range. Once I calculate interquartile range, now I have to multiply it with 1.5. Friends, there are many articles. The very first article told that if you want to calculate outlier, you need to multiply interquartile range with 1.5. And many statistical applications, including Minitab, SPSS, many applications, they give 1.5 as a multiplication factor for interquartile range if you want to calculate outlier. However, the subsequent materials that got published where they told 1.5 may not be the right number, sometimes we need to consider 2.2, and in some publications later on they have told even we have to go for 3 as a multiplication factor. However, I am sticking to 1.5 because that is being used in many statistical applications. I would request you to do some research on the papers where they have given the logic of why 1.5, why 2.2, why 3. So you can go through those material. I'll also try and share the link of those papers where they have discussed about the multiplication factors in the description of this video. But as far as this particular formula is concerned, we will go with 1.5 times of interquartile range. Okay. Now what we need to do is we need to add 1.5 times of interquartile range to my P75. That means if this is my P75, then if I add 1.5 times of interquartile range, it turns out to be 8.25. Then if I have my P25, then P25 minus 1.5 times of interquartile range will make it 3.56. Will make it 3.56. So these are my outlier boundaries. So any data point falling above 8.25 will be called as an outlier, and any data point falling below 3.56 will also be called as an outlier on the lower side. So the logic of IQR method is, so you have your P75 and P25 values. The distance between these two values are called your IQR, interquartile range. 1.5 times of interquartile range will be calculated. Then P75 plus 1.5 times of interquartile range will be the boundary for your higher side, and P25 minus 1.5 times of interquartile range will be the boundary on the lower side. Now what we do, the same formula that we are going to apply. So we are going to say if yes, this value is lesser than this value, call it an outlier. Right? You can call it a outlier. The second condition is if this value greater than this value, then also you can call it an outlier. Yes, so this will be called as an outlier. So we will add the if not applicable formula to this. We will put a comma and then we will call it as not an outlier. Yeah, we'll copy this and paste it here. So if you see here, except for 3, everything is declared not an outlier. 3 alone is declared as an outlier. And how does this formula works? This formula works with a logic of whether your data point is falling 1.5 times of IQR above your P75, or it is falling less than 1.5 times of IQR below your P25, then that data point will be called outlier. If not, then this data point will not be called as an outlier. And box plot is one of the better tools when it comes to calculating, um, or when you are graphically want to look at whether your data have outlier or not, using this method, using the IQR method. Friends, I hope this video was useful for you to understand how you will determine whether your given data contains outlier or not, even though if your data is not normally distributed, using a method called IQR method, interquartile range method. So as we saw in our previous videos where I was explaining about the Z-score method, Grubbs test, and Dixon test, these are primarily for data which is normally distributed, and IQR method is for data which is non-normally distributed. So thanks for watching this video. In my upcoming video, I'll be explaining about when there is an outlier, how do you handle it? After you use this test, you identify there is an outlier, how do you handle it? Friends, hope this video was useful. So thanks for watching this video. Have a nice day.